this challenge has something to do with this candy bar. So there's a challenge. The challenge is when I arrived here on Saturday. My name is I forgot to say. My name is Lars Wischhof. I'm from Germany, Munich University. And when I arrived here on Saturday, I was really shocked. Why was I shocked? Because my original plan was to do some introduction to Android programming with you today. So I came and walked through the labs and I saw everybody's doing Android programming. And I thought, oh well, if I do my lecture here, then you will, if I have luck, you will all go to sleep collectively. And if I'm unlucky, then you will start throwing things at me and I have to leave. So I completely switched a little bit the topic. So originally I wanted to do a lot about Android programming, a little bit about Bluetooth. Now what we will be doing today is we will be talking a lot about Bluetooth and a little bit about Android programming. And the challenge is common. The challenge is there's exactly one slide which is from the Android introduction. So if you spot that one slide, you get the candy bar. Right? So that's the idea. It's an original Finnish candy bar, as you can see. Right? So. Okay, yeah, a few words about Munich first. As always, I think the two Alexes, they already showed you the nice movie about Munich. So you already know that Munich is a nice city with a large city, large university, a lot of things to see, good beer, so what else do you want, right? There's a little bit about our faculty. We are about 1,000 students, you know already 15 of them, so it's not that unfamiliar to come to Munich. We have 40, I think we have 48 professors right now, some additional lectures, we have some degree courses in computer science, of course, business informatics and so on. So if you would like to maybe continue with a master's degree at Munich University, you could do it in computer science, for example. We have specialization in embedded devices, in what else? Software engineering, computer vision, things like that. So. And if you don't want to come for a master's degree, maybe you would like to come for a PhD degree. So if you're really fast, we have 2 open positions right now for PhD students, but we're always looking for good PhD students. So topics are networking, computer security. We have some colleagues working on that, network security, and so on. So yeah, that's about all I wanted to say about Munich University. Talk to the students about the rest. And, of course, you can also ask me, or if you know someone who might be interested in these PhD positions, then also I'm willing to talk about that. A few words about myself, if we didn't talk yet. My main focus is in computer networking, so these are the main research interests also. If you look, there's a lot of wireless communication, Car-to-X communication, so the question of our vehicles communicating with each other, or vehicles communicating to some base station. If you have a modern car like a Audi A8 or BMW 7 vehicle, then you have all the infotainment systems in there which communicate with the outside world using the GSM or GPS, UMTS and LTE standards. So yeah, it's a little bit automotive related and wireless related is the conclusion. Okay, now let's get to the topic. What do we need? We need, of course, some research question, right? Before we start, we need some question to solve in the next 45 minutes. And the research question is, try to come up with an interesting question. It's not always simple. So the research question is the lecturer holding this lecture, is he maybe healthy? I don't know. We will see. Is he nervous? Could be. Yeah. Is he calm? Or is he even dead? So we will find out in this lecture, hopefully, what would a normal person do. A normal person could come up to me and ask me, right? So it would be a simple thing to do. How are you? And I would answer, and we have solved the problem. And then we can go to cafeteria, and we are done with the lecture, right? So this is the normal way, but we are computer scientists, so we don't need to talk, right? We don't need to talk. We can have technologies. We have sensors here, some pulse sensor. We have smartphones over here. We have wireless communication. So we will use technology to answer this question. That's the idea of this lecture. So what are the ingredients which we need? We need some technology, of course. So we will be talking about a little bit about the sensor which we will use here, heart rate sensor. Then we will talk a lot about wireless communication. How do we send the sensor value to the smartphone over there, so we can look at it. We need, of course, a mobile device or some device to display the value. And if we have these technologies, then we can do some implementation. So we can use some software, some APIs to program a small application which reads the value and displays the value, and then we know what condition the lecture is in. So that's the idea. If we have done all that, then we can test the application, and then we will see the result, and we are done. So let's start with the technologies. First thing in the technologies is the heart rate sensor. So I'm not a medical person, so my explanation of the heart rate sensor is, well, this is a little bit like you would see it maybe in a commercial. It's not very technical, but the basic idea is that you have such a heart rate sensor like this, and then you have some breast straps, you put it around your breast. Then the heart rate sensor is near the heart, right? And it has 2 electrodes, which you can see over here. And it will use these electrodes to monitor the electric activity of your heart and then detect the pulse rate in beats per minute, transmit this pulse rate using some wireless communication like Bluetooth, or there are some other proprietary protocols like this ANT protocol, which is developed by Garmin. But of course we will use Bluetooth, right? So otherwise the title of my lecture wouldn't fit. So we use Bluetooth. And we also need some volunteers to put the heart rate sensor on. So late coming people are always volunteers for using the heart rate sensor. So the basic idea is to use this heart rate sensor, and then we transmit the beats per minute value. By the way, what is the typical heart rate in beats per minute? Any idea? 75. 75, okay. So what would you guess, what's my heart rate right now? Any guesses?
180
80, okay. 110, okay. Let's see. 80, 90, 60. Okay. Well, we will see, right? So, I would be surprised if it's 60. So the typical value is for an adult, it is in the area of 60 to 80 beats per minute if you are in a calm state, so not very excited. For a well-trained adult, and I have to admit that I'm not a well-trained adult, this would be in the area of 40 to 60 beats per minute. And if you have children, these have much higher values. So small children in the area of 70 to 130. So if they are newborns, even higher.
Probably he has a volunteer for later on.
Okay, he's a volunteer for later on. Okay.
Sorry, keep up.
Thanks for volunteering. What kind of sensors do we have? We have this heart rate sensor, which we will be using here, but there are other kinds of sensors. So I've brought some examples which you can find on the webpage of the Bluetooth Special Interest Group, Bluetooth 6. So they are maintaining a list of devices which are compatible with this new Bluetooth low energy standard. And yeah, you find things like a glucose meter, pulse meter, oximeter to measure the oxygen in your blood, stethoscopes and so on, and yeah, these kind of sensors. So they are they're not that quite new, but maybe 1 or 2 years old, most of them, and use this new Bluetooth standard to transmit the data. And yeah, I have a list, or a link to the list on the webpage is in the slides. So if you're interested in maybe looking up some sensors for your own project, you can find it here in the slides at the end. Okay, so that's the sensor. We have now the sensor, now we need some wireless communication. It's the next step, right? And as I said, we use Bluetooth. So when Bluetooth was designed quite a while ago, there are 2 main design goals where it has to be cheap, so otherwise nobody would use it. And it has to use low energy, low power consumption. Drawback is if you have low power consumption, usually it means that you have low transmit power, and low transmit power usually means that you cannot get very far if you do not do many special things. So it reduces your transmission range. So we have rather low transmission ranges, but we have low power consumption. Okay, so one of the features of Bluetooth is in the 2.4 gigahertz ISM band. ISM, what does ISM stand for? Anyone know? It's industrial, scientific, and medical, so it's a free, license-free band for industrial, scientific, and medical applications. So, yeah, medical sounds fine. Okay, so let's use this frequency band. It's quite crowded. So, as you might know, wireless LAN is also sending in this, or some wireless LAN standards like the B and M standards, G and C standards are using this frequency band. What other devices are on this frequency band? Anybody know? Microwave, yes. This is a problem because microwaves always have some spurious emissions, so might influence your Bluetooth or wireless LAN communication. It's a quite crowded frequency band. You have baby phones in there. Small frequency band, but it's free, so everybody uses it. A lot of people use this frequency band. Bluetooth has 79 channels. This is what I'm talking about. It's now the classic Bluetooth. You'll see the changes if we go to this low energy or smart Bluetooth new standard. But here we have, for the classic Bluetooth, we have 79 channels, each 1 megahertz wide, so in total about 80 megahertz which we occupy. And then of course we need to transmit the bits. So for transmitting bits we need to change the signal. And we can do different things with the signal. We can change the frequency, which is what we do for the low data rate Bluetooth things, and for the enhanced data rate, the higher data rate classical Bluetooth standard, they shift the phase, so the timing of the signal is shifted. Then if we have multiple stations using the channel, we need some multiple access technique, and what we do is something different than what we know from wireless LAN. Maybe wireless LAN, as you might know, uses this CSMA-CA, so carrier sense technique. Bluetooth does something different. They have time division multiple access with fixed slots, so they divide the time in slots of fixed length, and then you use one slot for your packet transmission. And yeah, as we said, this frequency band is quite dangerous. We have microwaves sending their, wireless LAN sending their, baby phones sending their. So what we do is we do not use one channel constantly, because this channel might be disturbed by interference, but we start to hop around the channels. So we randomly hop between it's not really randomly, because the receiver of course must know where we are hopping to, but the sender pseudo-randomly jumps between the different channels. So we avoid the interference by jumping very fast between the different 79 channels. This is also a little bit different when we come to the low energy variant. So we will see that here we jump very fast. For the low energy Bluetooth we jump a lot slower. This is called frequency hopping spread spectrum. So we spread our transmission over a large spectrum range by hopping between the channels. So that's a classic Bluetooth. There are different classes of devices which identify how much transmit power you are allowed to use. So the class 1 device uses 100 milliwatts or 20 dBm for transmitting packets, which is the same value as wireless LAN uses. And you get about the same transmission range, like 100 meters. And higher classes, class 2 and 3, they use less transmit power, also less transmit range, of course. And then there's no such thing as the Bluetooth standard. There are different standards. First standard dates back to 1999, and we have seen continuous improvement. So as you see, the data rate increases. Then we introduced higher data rates. We introduced with 2.0 enhanced data rate, which uses this PSK modulation scheme. Then we have improved the pairing. Then there's another variant which allows to transmit Bluetooth packets over wireless LAN signals. And then what's interesting for us is that the low energy smart has been introduced. This is what we will be talking about now. So for the rest of the lecture, we use this 4.0 standard of the Bluetooth. with this new wireless stack, which allows us to transmit with lower energy. Okay, so how does this work? The Bluetooth specification is divided in two parts. You have the core specification, which you can download from the website, of course. And this talks about what's the physical layer like, what's the link layer like, how do we use access scheme, and so on. So the basic technology is defined in this core specification. And then we have profiles which say in detail how we apply Bluetooth technology to a specific case. And I think the two Alexes also talked about the health device profile. This is one of the profiles for classic Bluetooth, right? So here we see health device profile connecting medical devices. This is not what we will be using today. We use a different profile. We will not use this health device profile. Because these are the classic Bluetooth profile, we will be using this low energy stack, right? There are different profiles. For example, serial port profile, which your GPS receiver uses to transmit the data if it uses Bluetooth. Or what else do we have? Profiles for audio streaming, hands-free, telephony in the car, and so on. Different profiles. Okay, so let's talk about this Bluetooth low energy variant now, which is also called Bluetooth Smart. Well, smart is always good, right? So Bluetooth Smart is another name. Bluetooth low energy is maybe the better fitting name. So why did they design this low energy variant? Well, the thing is that companies started to develop such kind of sensors and wanted to connect them with the smartphones or other devices. And they found out that if they use classic Bluetooth, that uses too much power. So they developed own standards. For example, this ANT ARM standard was developed by Garmin. And these were proprietary standards. And well, the Bluetooth special interest group, they were not amused, as you can imagine. So if they see that there's another standard being used for transmission between those devices, they said, okay, we need to react, we need to have an own Bluetooth variant which uses less energy. And this is this Bluetooth low energy variant. So version 4 introduces this new stack, and what do we need to transmit less transmit power? Unfortunately, we need some new physical layer. Which means you need a new chipset, new type of hardware. So you can only use this Bluetooth low energy if you have a relatively new smartphone, because only newer smartphones will have this new hardware which you require. And you need, of course, an operating system which supports this. For example, Android Jelly Bean and higher versions. iPhone supports this, and what else? Yeah, and you need, of course, a smart sensor, some sensor which is able to transmit. So if you have these two components, then you can build your application. Also, we need to stress that it's an optional part of Bluetooth 4.0. So just because your smartphone or your device says it's Bluetooth 4.0 compatible, doesn't mean that it also is able to use this low energy variant. So it's an optional part. Some devices support it, others will not. Okay. For saving energy, we need a new physical layer. What's the task of the physical layer? In 2 words, maybe? Fun?
Defines the physical aspects of the
Okay, that's an academic answer. We could put it more simple. Just transmit the bits. Yeah, we want to transmit a single bit, maybe. Okay, or multiple bits. So physical layer is considering transmission of individual bits, some bit streams. And what you see is that they modified the physical layer. So we are still in the 2.4 GHz ISM band. Not much choice because there are not that many bands which we could use. But we do not use 79 channels, we use 40 channels. So we reduce the number of channels, but we increase the width. So it's from 1 MHz, it has gone up to 2 MHz. And so in total, we still use about 80 MHz total bandwidth. Output power, we want to use less power, so we reduce the output power. See here, and we will adapt the power to the power we really need to reach the other device. So the power control scheme applied. How do we transmit the bits? As you might remember, we had two choices for the classical Bluetooth. We had frequency modulation for the lower rates and phase shift keying for the higher rates. What do we do here? We use some variant of frequency modulation. So we shift the frequency to transmit the bits. And the maximum transmission range which we get is about 10 meters, which should be enough if I'm wearing the sensor right and holding the smartphone in my hand. My arm is usually not that long, so it would be enough with this transmission range. Next layer which they changed is the link layer, class of the link layer. Yes. Physical layer transmits the bits. What does the link layer do?
Shut off the connection.
What?
Shut off the connection.
Yeah, so it's transmitting some data between on one hop, between two stations on one link, we could say. That's why the name is the link layer. The link layer for this low energy variant, they define it the following way. They say we have in total these 40 channels, and we divide them in two classes, two types. So one type is for advertisements. 3 channels we use for advertisements, where we, if we have such a heart rate sensor, my smartphone needs to know that there is a heart rate sensor. Right? So you will start advertising, hey, I'm a heartbeat sensor, would you like to use me? Yeah? So this is the advertisement channel. And then we have the data channels, remaining 37 data channels, which we use to transmit the data. And we also use the TDMA scheme. We still hop between the channels, like with the classical Bluetooth, but we hop a little bit slower. So we have a lower hopping rate, which means that the timing requirements, so how exactly I need to know where my sender is jumping right now, the timing requirements are reduced, which makes it easier to implement, uses less energy. And then we have 5 different states which we can be in. Well, this sensor, for example, is now in the standby state. Right? Doesn't transmit anything, doesn't receive anything. Why not? Because it's not connected. So the electrodes are not connected, so it will do nothing. It's in standby state. If I want to find it, my smartphone, I switch it on and say, okay, scan for the heart rate sensor. Smartphone will switch to the scanning state and will be listening to the packets on the advertising channel. So if there are heart rate sensors, they will, my smartphone will receive it and will display a list with all heart rate sensors in range. But of course, it can only find devices if they are advertising, so the device itself needs to be in advertising stage. Okay, then on my smartphone, I select the device and I want to establish the connection. So this would mean my smartphone switches to the initiating stage. It wants to initiate a connection, a data connection, and will only listen and answer for specific packets of this specific heart rate sensor. So that's the idea. And then, of course, there's connected stage where we are connected and are exchanging the data values. Okay. Link layer continued. Of course, we have only 37 data channels, but if every one of you would wear such a heartbeat sensor right now, it might be difficult to transmit the data. So we need to do something about it if we have more devices than transmit channels. And one thing is that what we do is we have a specific access address in front of each data packet, so this allows us to distinguish between different data connections which we have. And also, well, we need to do something about security, because maybe I do not want you to know my heart rate right now, so we do something about security. Bluetooth Low Energy has 2 variants. We can encrypt and authenticate, so we can use a cyberblock chaining technique. So using previously encrypted data blocks as a random input for encrypting the next data block, standard technique for encryption. And then we can also authenticate the device. So we can either have a data connection which is encrypted and authenticated, or a data connection which is not encrypted, not authenticated. The 2 devices, the 2 different variants of communication which we have. It depends on your requirements which one you use. Okay, so this is the physical layer and link layer of the new low energy standard. What else do we need? Well, we need some protocol to access the data. So just because we have a physical Bluetooth connection doesn't mean we can access the data. So we are now moving in the direction of this profile. Right? I said we don't use the health device profile, we use a different profile. And this profile is called the generic attribute profile. And the generic attribute profile makes use of something which is called the attribute protocol, which is a protocol for discovering, reading, and writing attribute values. So very generic approach. So for example, you could discover the sensor attributes, you could read an attribute, for example the heart rate, and I hope you cannot write my heart rate. This would be dangerous. Right? But for some attributes it might make sense that you also write the attributes. For example, we will use it to write the configuration attribute. Now this attribute protocol defines two roles. It defines a server role and a client role, which is a classic thing from communication. Who's the server, who's the client? Well, the server is the one who has the attributes. So in this case, this is the server, and the client will be our smartphone. Such an attribute has 4 different parts. It has a specific type. Type is the question, what type is this attribute? So is it the heart rate, is it a power value, or what is it? And every type has a so-called universally unique identifier, a UUID. We know that from many other protocols also, and so if we want to access some value here on this device, we need the UUID of this attribute. So the question would be, how do we get this UUID? Then we have an attribute handle. Attribute handle is required if you want to modify or want to read a specific attribute. You need such a handle. A handle is one attribute on one specific server. So it's not the type, it's one handle on one handle identifies exactly one attribute on one specific server. So if I want to write a new value to this, I use this handle. Then we have some permissions. Am I allowed to read, to write, and so on. And the value of itself, of course. Okay. Last thing about this attribute protocol, if we want to access the data values, we have two choices. We can ask the heart rate sensor what's the current value, so it's a request response. I request the new data value, he replies, okay, it's maybe 90 beats per minute, right? But this might be complicated if I want to show maybe a graph with the current rate. I need to ask and wait and ask and wait. So other choice is that we register for notifications. So we tell the sensor, the attribute server, we tell it, okay, I'm interested in your attributes, notify me whenever the attribute changes. This is what we will be using for the heart rate, so we tell the sensor, notify us whenever the heart rate changes. Now we have the protocol, now we still need the attribute profile, the generic attribute profile. And this is a Bluetooth profile which makes use of the attribute protocol, so you can see here. This is our stack, so we have the Bluetooth controller down here. On top of it, we have the link layer protocols which unite kind of which is used in many Bluetooth stacks. The link layer controller, the adaptation protocol, makes using the physical layer more easy. So it's a typical adaptation layer which is used in many Bluetooth protocols, nothing special. Then here we have the attribute protocol which we discussed, and then we have our application running on top of that. And yes, so we have a relatively generic profile which we can adapt to different situations, and this is what they do. So they have defined generic attribute profiles for very many different sensor types. So each profile is itself composed of services. Such a service could be heart rate service running on this device, right? So we have some services, then we have some characteristics. The characteristic is, for example, the heart rate measurement, which is done by this sensor. And then each characteristic has some value, which in this case would be the heart rate value in beats per minute, in this example. And you can download all these different profiles for heart rate sensors, for pressure sensors, and so on. You can download them on their website. So there are different profiles for thermometers, heart rate, location, navigation, phone, and so on. So many different profiles. What we will be using is this heart rate profile. Okay? So you can go to the website, download the heart rate profile, and get some XML. What does it look like? Looks like this. Yeah, so XML. What do we see in the XML? We have some information. This service exposes the heart rate and so on. We have some requirements. What is required to use this profile? Transport. Here you can see classic transport is not allowed, so we cannot use this profile with classic Bluetooth. It's only allowed with low energy. And we define the characteristics. Here the characteristic heart rate measurement. So we get some heart rate measurements. Okay, so we are all set now, right? We have all the information we need. Can start implementing with the implementation. No, not really, because if you remember, we need this UUID, this unique identifier of the heart rate. Anybody spot the UUID in the XML?
Yeah, that's in the top.
Yeah, here, right? The UUID is a 128-bit value. This is 128 bits. How many bits are these? 2 bytes, so 16 bits, right? 16 bits, so we need to guess the remaining 112 bits. Yeah. So let's start guessing. 0. No, unfortunately it's not 0.
Okay, sorry.
Too bad. Yeah, so guessing is also not a good option, right? So turns out that for the service discovery, even the Bluetooth people thought that specifying 128 bits is not a very nice thing to do. So they use short versions of the UUID. For example, this is a 16-bit short version. And then, of course, in order to access this from some software, in order to access this device, we need the full 128-bit value. So we need this some way to inflate this to a 128 bits. And adding zeros is not done. So what we do is the following: use some base UUID, which is this one. This is here. And then we use our short UUID. Then we simply combine them. So this would be looking at the XML where we got this red number. This would be the resulting 128-bit value to access the data on the sensor. Okay, but now we have everything. We have the UUID, we have sensors, and so on. Just one thing is missing, of course, the smartphone, right? So, bingo! Okay, you got it. Yes. Okay, yeah. So this is the slide which is left over from the smartphone introduction, right? So as you might know, the smartphones, Android smartphones, they have some Linux kernel below, then they have some libraries. Then we have some application framework where we have the application libraries like the Bluetooth library which we will be using. So we will be doing the implementation here on top, the application layer. And then we use some Bluetooth libraries to access the Bluetooth functionality. Of course, the Bluetooth functionality itself would be here down in the kernel with some drivers, right? But it's not really fun using that. Okay, but now we have everything. We have all technologies. Sensor, Bluetooth, mobile device, and can start with the implementation. Right? Okay, implementation. What do we need to do? What do we need to do? It's not that easy as you might think, because first, of course, we need to know if our device supports Bluetooth low energy. So we need to check, do we have Bluetooth low energy? And if it's available on the smartphone, we need to check if it's enabled. Right? If it's not available, then we need to tell the user that he needs to buy a better smartphone. Okay, sorry. If it's not enabled, we can tell him to enable it. If we have Bluetooth, then we need to scan for the heart rate sensor. If we have found the heart rate sensor, we need to discover the heart rate service. Oh no, first we need to connect, okay? We need to connect, of course, to the attribute server, and then we can discover the heart rate service, which is where our UUID, the long UUID, which we got from the XML, short version of the XML, comes in. So now we have the heart rate service. Now we need to discover the attributes, the characteristics. And within the characteristics, we hope to find the heart rate measurement, right? And then we register for notifications on the hardware measurement, and when we get the notification, we will display the new value, and then we have solved our research question. So this is the plan, right? 7 steps means 7 slides. So each step 1 slide. A little bit of Java code, but not so much. So we need to know if we have this Bluetooth low energy. How do we do it? We ask the package manager if we have it. If we don't have it, then we say, okay, sorry, buy a different smartphone because this is that. Okay, then next step was we need to check if Bluetooth low energy is enabled. Who can we ask if Bluetooth low energy is enabled? Well, what do you do in real life if you want to get some technical information? You ask a manager, right? So, and the manager will tell you someone who knows if what the real answer is. So that's what we do. We ask the Bluetooth manager, yeah, give me some Bluetooth adapter, and then we can ask the Bluetooth adapter, is the Bluetooth enabled? If not, we need to show some dialogue to ask the user to enable it. If it is enabled, then everything is fine. Okay, so let's continue with step 2. Step 2 was we need to scan for the device. Yeah, for scanning, this takes a long time, right? It takes a long time to wait for the devices. They can appear and they can disappear. So we do not want to wait in a function call, in a method call until the scanning is completed. So typical thing to do is we define a so-called callback, which is called whenever the device is discovered. Right? So we define a Bluetooth adapter low energy callback, and this callback has a method which is called on low energy scan. And whenever our Bluetooth adapter discovers a new device, this method is executed and we can react. We can, for example, add it to a list of devices, and the user can select a device and so on. Yeah, then we need, of course, to start the scanning, which is simple. We just call start low energy scan. If you have ever used regular Bluetooth in your Android applications, this would be start scanning, right? Or start scan. Here we do a specific scan for low energy devices. So it's LE scan for low energy devices. Yeah. So this is a standard method defining a callback. What other choices could we have? Android experts. What other variants would be there to have a non-blocking way to notify someone that something is available? No? Where we could block simply the start scan method, which is not a very nice thing to do, right? Or what could we do? Well, there's a thing called intents in Android, so we could send an intent when the device is discovered. It would be another choice, but what they decided to use is such a callback variant, so callback gets executed whenever we find a new device. So we have found the new device. Next thing is we need to connect to the attribute server. Oops. And yeah, it's about the same way to do it. We define a callback for reactions on which are coming from this attribute server. And we have different methods. One is the on-connection state change method, which is called whenever the connection state changes, obviously. So if we get connected, this method will be called. And also, here are 2 additional methods. One is for service discovery, and one is for changes on the characteristics, so for changes of the hardware. Now let's connect to the server. So we call on the Bluetooth device. We say, okay, we want to connect. Give him the callback. And then we connect to the server on the heart rate sensor. It will answer when it's available. The connection state changed method will be called, and we can continue discovering the services. Same way of communication, defining callback, and then starting the service discovery. So we call discover services, and whenever we find the services, we get called, and we can iterate over all services. And when we find the one which is our heart rate, so the UUID is equal to our heart rate UUID, which we got from the XML and have blown up, inflated to this 128 bits, then we know that this is our service, we can connect, and everything's fine. Okay, now we have the service which we are looking for. Now we need to do a for each loop, for example, to find the specific measurement of the heart rate. So our heart rate service defines different characteristics, and one characteristic is this heart rate measurement. So we need to find that, and then if we have found it, we will register for notifications. How do we register for notifications? Well, it turns out that if you just call this set on notifications method on the server, this is not enough. Why not? Because the heart rate sensor, all Bluetooth low energy sensors, in their default state, they will have all sensors deactivated for power consumption reasons. So we not only need to register for notifications, we also need to turn the sensor on. This is what we do here. We configure this attribute on the server and say, okay, please switch my heart rate sensor on and transmit the data. So this configures it that it's on, and then we say, okay, we want notifications. Okay, now last step, processing the updates. When processing changes, we need to get the value. There are two different formats, so we need to check which value is it in. Is it a 16-bit value or an 8-bit value? And then we have the current heart rate, and we can display the heart rate. And we are done. Okay, 7 steps. This is the last step. We have the heart rate. Everything's fine. Any questions? Okay, so let's test it, right? So what I did is I copy-pasted all the code from the slides, because PowerPoint cannot run our Java code yet, right? I copy-pasted it to one activity, and you can download it if you want to try it yourself, or do not believe me, but it's exactly the same code. So we will find the different steps here, and these are doing exactly the same as we now did on the slides, right? So let's start this application. Let's see what happens. Connected my smartphone, as you can see. Okay, so we get some heart rate measurements, right? And okay, as you can see, it's not really the calm state right now. Okay, where do the measurements come from? Anybody know? Simulation? Right, so I'm wearing the second one. So this is the real measurement. You can try it yourself with this one. So we have 2 sensors, so if anybody wants to try the second one. So for all the Linux guys, this is enough, right? The problem is solved. We have text output, everything's fine. For the more advanced people than the Linux guys, maybe we should at least do some improvement of our application. So what might we need to do? Well, maybe we want to process the sensor readings in the background, so we can define a service, Android service, which runs in the background. So even if I'm using the web browser, it will process the heart rates. We might want some nicer user interface. So, well, comparing this heart rate sensor values with some indication values to say, okay, the person is alive, is dead, or is nervous, and so on. And maybe also some graphical display where we could use maybe some libraries, right? Like GraphView library and so on. Okay, so this is the second version, but we will not look in the source code. You can download it if you want. It's a little bit more advanced heart rate monitor version. So as you can see, currently we do not have any heart rate sensors here. let's start scanning. So in this case, we now send this scan request and we see, oh, somebody else is having a smart device. Who is it? Lex? Okay, so this is the sensor which I have. So we did register for this value. Okay, you see that it changes. So let's test it and do some sports. Maybe a little bit. It's too bad. Yeah. And also there's some small graph display that it can. Oh, okay. So obviously, when I tested it, it used to be here. Yeah. So scaling is a little bit off right now. But try it yourself. It's fun. Yeah. So this is the end phase of this practical part. So we see that we have connected to the sensor, we get the sensor values, and we have some way to display it. If you look in the Android developer parts, there are other applications. So we can, of course, use different sensors, use other ways to access it. The examples which I have, they are quite long, quite complicated. So this is why I decided to have a smaller, simpler example. But they are also very interesting. Okay, so we've improved our app. If you want to program your own sensor application, what do you need? Well, you need some software, you need some hardware, Bluetooth 4.0. And if you want to take a look at the standards, they are also publicly available, so you can look what profiles you need. Maybe if you have, no, nobody tells me that it's not going to use it. Yeah. So if you want to program it yourself, you can download the profiles and standards. They are all publicly available. And if you want to take a look at the Android developer guide, there's also quite a good guide on how to use it, which goes a lot beyond that what we talked about right now. Okay, so that's about it. If any questions, you can download the example code from that webpage, or we can also upload it as to these web pages.
If you have a link, it should be enough.
Okay. Yeah. Okay. So thank you for listening.